online. So today I'm going a bit deeper on YugabyteDB, right? So that will be kind of series, right? Every meetup, I'm going to talk about something different, but on the same level, right? So today's agenda, I will just give a quick reminder and what is under the hood for the tablet, what we call tablet splitting, and the replication. So quickly about me, if you don't know me, my name is Gwenn. I'm a Principal Solutions Architect at YugabyteDB. Yugabyte, sorry. I joined last October, right? So I'm quite new still. And before, I used to work for Gwenn Etourneau, Pivotal, Rakuten, IBM, and some other company. This is my Twitter and my GitHub. Okay, so just a quick reminder. So quickly, on the component of Yugabyte, right? There is two main components. One is called the T server services, right? Which is basically the one who stores the data, right? And it will also serve the data, right? From the tablets, but it's basically shards. And then we have the master, which manage the chart data, the metadata, right? And if there is any config change, we'll correlate that, right? Most of the time, we install those two services within the same node, right? But if you have higher volume or whatever, we can, of course, separate them, right? They don't have to be on the same node, right? But for now, we just install with the same node. It's really up to you. On Kubernetes, obviously, it's a different pod, right? But most likely on VM is the same. So YugabyteDB is a layer architecture, right? You have the query layer, right? Which basically your application client is going to talk to, right? And we support multiple API in this query layer, right? So the YSQL, which is the Postgre, right? Compatible. And the YSQL, which is the Cassandra, right? And of course, in the future, even more, right? And then you have the storage layer, right? Which is doing distribute the data, right? Manage transactional and so on, right? And this is .db. We call that .db, but it's based on RocksDB. So again, for example, if your microservices is requiring relational integrity, then SQL, right? For massive workload, then YSQL, and of course you can use zero distribution, a part of that, right? So it's very important that there is this two layer. So a bit more on the Postgre layer, because I think it's important. On the left, this is kind of common Postgre, right? You have the query layer, and you have the Postgre storage layer, right? It's kind of monolithic within one node, right? In YugabyteDB, we basically reuse the query layer, right? We use the same code. Of course, there is a bit of change, right? To support a different storage layer, right? But this is the same code, right? If you look and you go to YugabyteDB on GitHub, you will see this is the Postgre code, right? And the difference is mainly on the storage layer, right? Where we can scale, and every node is the same. We don't have a supervisor checking for something, an observer or whatever, right? This is truly distributed, and you can scale the node. So now I want to talk a bit about table sharding, right? So Yugabyte is a distributed system, right? And for that, we shard table, right? So every table in Yugabyte is automatically sharded, right? YugabyteDB split those tables in multiple shards, right? In Yugabyte, we call shard tablets, right? So that's why I'm going to use tablets from now on, right? And the way we shard into tablets is we use either a hash or a range-based strategy, right? So we use the primary key for each row, which basically identify the location of the data, right? And then by default, the default is 8 tablets per node, right? Which is distributed across them. I will go a bit more in detail for that. So again, you have your table with all your rows, and then we split them in tablets. But again, YugabyteDB allow you to reshard those tablets using 3 mechanisms. The first one is pre-splitting tablets. Basically, when you create your table, the time of creation, then you can put the number of tablets or split you want at the creation time, right? Then you have the manual tablet splitting, right? Which is, you can do, of course, when you create, but after, at the runtime, right? Let's say your table is already created, you already have tablets, then you can split those tablets, right? And then the last one, which is kind of new, it's not very old, which is called automatic tablet splitting, right? So you will let YugabyteDB decide the splitting for you, right? So pre-splitting, right? Again, this is at the creation time, right? Where you create the tablet. You can say, I want to split, for example, this table into, in this case, 16 tablets, right? 16 shards. The way it works, so for YSQL, we support both range shard, and hash shard, right? For SQL, sorry, we only support hash shard, right? So the way it works is, you have your primary key, right? Whatever the value, right? And then from that, we are going to apply a hash function to calculate basically the hash value, right? And based on the hash value, we are going to put that into bucket, right? So for example, in this case, the table will be divided in 60 tablets, right? And the overall hash space will be between 00 and FFF, right? So we are going to divide in 60 pieces, right? 1, 1, 2, etc. When you have a read and write, we are going to use the primary key to define the location of the data of the row. So for example, here, you want to insert into T, key be value, key be the primary key, right? So we are going to calculate the hash value of this. For example, in this case, let's say 1, 2, 3, 4, right? And that's going to be in the tablet 2, right? Between 100 and 200, right? This is just an example. For the range shard, it's a bit different. Basically, we don't use hash function. We just use the value, right? So for example, if the primary key value is 1, then it will be there, right? And you can, again, pre-splitting, you say, I want to split at 1,000, 2,000, 3,000, 4,000, right? So 0 to 1,000 will be in the first bracket. 1001 to 2000 will be the second bucket, right? So here, 1 will be first bucket. 1001 will be in the second bucket, right? After. Because this is the way I decide to split that, right? So this is the pre-splitting, right? This happened at the creation time. You have to know that there is a maximum number of tablets that you can create by node, right? By table. There is a settings, what we call flag or G flag in Yugabyte, where you can define the max create tablet by T server, right? Of course, you can change the setting, right? Default is 50. So for example, if you have 4 nodes, then you can only create 200 tablets by table, by node, right? By the host. If you try to do more, then you are going to have an issue. So in this case, you need to rethink the way you want to split, right? Or you may want to increase that, right? Now, let's talk about manual tablet splitting, right? This used to be recommended in version 2.14, right? Before. So again, you can do during the creation time as well, right? Split into X tablet, right? The same as before. Here, I want to split into 1 tablet, right? But you can also use the YB admin command to split tablet. So this tablet right in here, I want to split in 2, right? Then I can use this command to split, right? And this is basically at the runtime, right? Because the table is already created, you already have data, right? But still, you want to split this tablet, right? So you can use. That's why it's different from pre-splitting, because pre-splitting is really at the creation, right? The manual is after the creation. So now let's go to the new one, which is basically now the recommended one, I would say, is automatic tablet splitting, right? So you will let YugabyteDB decide for you, right? This will happen online, transparently, right? When a specified size threshold has been reached. I will explain that. If you want to enable that, it's basically a flag again. Enable automatic tablet splitting, right? And of course, there is other flag that you have to specify for the threshold, right? When you use automatic by default, the new tablet, the new table will have only 1 child, right? 1 tablet by default. Start from 1. In this case, there is 3 phases. What we call the low phase. Of course, this is defined by this flag, right? So you can change. This is just the default one. So the low phase means if you have less than 8 tablets, right? Less than 8 tablets. Then it will split the tablets which are bigger than this, right? So of course, your table gets more data, then more it will split, right? That's the low phase, right? So between 1 to 8, 7, I don't remember if it's plus or just 8, but between those, it will split at 512 megabytes by default. Again, you can change. Then the next step is what we call the high phase, which is set by this flag, tablet split high phase, right? By default, 24, right? So between 9 to 24, 8 to 24. If you have more than 8 tablets, right, that means this one has split more than 8 tablets, right? Then you will go to this phase, right? To this phase, you need to be less than 24, right? So between 8 and 24, right? Then in this phase, it will start to split to 10 gigabytes by default, right? So meaning the tablet will grow, right? Like the 9 tablet maybe start to get in here. And when they reach 10 gig, then they will split them, right? That's what we call the high phase. And then we have the final phase, right? The final phase is if you have more than 24, so 24 and beyond to the max, then it will start to split tablet at 100 gig, right? So we keep splitting at 100 gig. So this is the 3 phase of the automatic tablet splitting. And this is recommended for 14.9 and onward. One thing which is important is after a split, a compaction needs to happen, right? Because you may have unnecessary data, right? And you want to free the disk, right? So when a split happens, a compaction will happen, right? If you have enough resources, if it's the low phase or whatever, it may be okay for the CPU, right? But the compaction consumes CPU, right? So you may want to control how much CPU the compaction can use, right? Or resources, right? And this is possible with some GFlag, right? I didn't put them here, they are in the documentation, but just to know that if you see the CPU bumping after splitting a tablet, then you can control this behavior here, right? So that was the 3 way of sharding, right? Tablets. Now quickly, hash versus range, right? Well, basically, in Yugabyte, at Yugabyte, we recommend hash by default, right? That should be for most of the workload. It's best for massive workload, and you have a better distribution across that, right? Because they are distributed. The range, most of them will go here, 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 right? But it may be inefficient if you want to query the primary key with range, right? Key super v1, v2, right? But again, by default, you should use hash, right? You should only use range in a specific case is where you have this in the primary key, right? Because when you have that on the hash, that's meaning it may have to go to different tablet to find it, right? Here in Node, for example, this value will be within this range or within this range, right? So it's going to do less RPC, less code or whatever, less seek, right? But there is some cons, right? There is a rounding issue first. If you don't pre-split, basically by default, because it's a branch, everything will go to the first tablet because it will start. I mean, the first node tablet, right? Because you want to put them within the same branch, right? It may lead to hotspot, right? If you have a lot of primary key within this range, within the same tablet, that means they may go to the same node, right? So there is some cons that they need to be careful for the range, right? Again, we really recommend the hash unless necessary. Okay, so now I want to talk quickly about the replication. A bit over time, but yeah. So you remember the table is shard, right? But it's not the only thing. Those tablets, so the shard, are replicated, right? Because we want havability and so on and so forth. So they are replicated. They are shard and replicated. For example, in this case, the tablet one have a leader and 2 followers, right? Again, your tablet across node, right? And in this case, it's a replication factor 3. That means you have 3 copies of the data, right? 1 with the leader and the 2 others follower. And that means in this case, you can resist to, if one of them is down, this will still work, right? What we are using is pretty well known, right? We use the Raft consensus algorithm, right? For example, etcd uses it. A lot of new application, distributed system use that, right? And it works. I'm not going in detail there because there is a lot of documentation on the internet and better example, but basically, you will have a leader which is going to be elected, right? Or so here you have a quorum, right? That's right. And then, for example, this one has been elected by the majority, right? So it's going to be the leader. So when the read happens in Yugabyte, by default, the read always goes to the leader, right? There is an option where you can read from the follower if you want, right? If you have a very specific case, right? But you need to be careful of the latency and so on. The write only processed by the leader, right? Not the follower. And of course, for the write to be commit, the leader will wait for the majority to act the change, right? That's why you always need the majority. So leader is another addition to that is we are going to give a list to the leader, right? That means I'm going to be the leader for, I don't know, X sec, right? So when you have network partition, for example, in this case, this one, which is partitioned from the follower, will stop holding the list, right? So even if the client try to be there, the list will be with the new leaders. So you know that you can write them here and read here. Of course, there is a few seconds where it's still possible to read to the old one, but if there is no new write, of course, right? Because you could not write to this one because you need to acknowledge, right? But there is, I think maybe like 2 seconds, where it's possible to still read from that if there is no write, right? Because after that, the new election is coming and so on. So IO path, and that will be the last. So what is the IO path when you want to do a read, a write, or a transaction? This one is quite simple, right? So your client, we already know the tablet. We already know. Basically, I want to read this, right? So we are going to calculate the hash, right? And we know it's tablet 3, right? So what is going to happen is you can connect in Yugabyte, you can connect your client to any node, right? Any node. It doesn't matter if the node doesn't have the data, right? So this one is going to ask, hey, give me the leader position, right? To the master leader, right? Because as well, the master is distributed, right? Or replicated. And this guy is going to tell you, okay, the tablet leader 3 is there, right? So it's going to redirect to this one, and this one is going to send back the data, right? And then respond to the client, right? So the important there is the leader know where is the leaders, right? The client may cache for some time as well. I think the smart driver is doing that from Yugabyte. But still, the master always knows where is the leader. So the write, again, this is not a transaction, right? It's a single row. Insert is employee, whatever, primary key. the employee ID. It's kind of the same. You want to update on tablet 3 because you know you calculate the hash value, right? So we know that is the tablet 3. Go to the server 2, give me the location, send the query to that, to this one because the leader is here. And here the difference is it will basically, of course, wait for the majority to act, and it will synchronize, update the follower, right? And that using Raft. And then respond to the client, right? It will respond to the client when basically the majority act, right? You don't need to wait for all of them to act. Distributed. So this one is more like a Cassandra one with the start, but it could be begin transaction, SQL. There is this distributed transaction manager, right? And this is the component which is, this is the component within the T server which is going to help us with the distributed. So for the right, basically your client say, hey, I want to set the key 1 v1, the key 2 v2, right? So the first thing he's going to do is going to create the status of the record, right? If it's committed, pending, abort, whatever. Then transaction manager will write provisional record, right? They are not committed yet, right? We will write that in the tablet, leader, which contains key 2 and key 1. And then when you finish to write the provisional record, is going to commit the transaction, right? So it's going to update the status in the transaction status tablet. And then you will act to the client, right? And then what happens after, asynchronously, you will convert those provisional records to permanent, right? Of course, the client doesn't know it's a provisional record or not, right? It will do that in the background. The read. So I want to read key 1, key 2, right? One important, so as you know, key 1 is there, key 2 is there, right? The important thing is what we call the hybrid time read, right? We want to get the transaction, the value, not transaction, at the time of the client request, right? Because you may have ongoing transaction as well, right? So we want to be sure that we're reading the one which are before this one. So you know that there is provisional record with the transaction ID, right? And it's going to request, is this transaction commit or not, right? Can I use this transaction? Those values. And instead you say, oh, this one has been committed at the time 100, right? So this means it can return those values. So it's going to return those values and then respond to the client as the transaction return. And with that, that's all for me for today. If you have any question, I'm a bit late, but do you have any question? Yeah, I guess no question. Yes.
So YugabyteDB has two YSQL and YSQL, right, on the query level?
Yes.
How does it change under the hood? Is it like a different systems?
So
it's just a query level.
Just at the query level, right?
So
the storage is the same. So basically, with one cluster, you can have YSQL and YSQL within the same cluster.
And they can use like both on the same time?
You can do both, but you cannot, I think, by default, talk from SQL to SQL, right? There is something called foreign data wrapper where you can try to do something like that. But by default, you cannot communicate with other. There is some way to do it with some option, but not by default.